Welcome to the DIY Honda Garage channel. The DTC P0204 indicates a malfunction in the number 4-cylinder injector circuit of the Honda Pilot from 2016 to 2022. This fault prevents the proper functioning of the injector that supplies fuel to the number 4-cylinder. The main components involved in this circuit include the injector relay, the injector control module, and the powertrain control module, PCM. The injector relay is typically found in the underhood fuse relay box, while the injector itself is located near the respective cylinder head. The operation of each part is crucial for the engine to function efficiently, as they control the fuel delivery into the cylinder. If this DTC appears, it may lead to poor engine performance, increased emissions, or engine stalling, requiring careful troubleshooting and diagnosis. DTC P0204 signifies a malfunction in the number 4-cylinder injector circuit. This potentially impacts the vehicle's performance, leading to issues like misfiring, stalling, or rough idling. The main components affected include the injector relay, which controls the electrical supply to the injector, the injector control module, responsible for moderating the fuel delivery, and the PCM, which oversees the overall engine management. The injector relay is typically situated in the underhood fuse box, while the PCM is in the engine compartment. Understanding this fault is crucial as it directly affects the combustion process of the number 4-cylinder, which may result in diminished power output or increased fuel consumption. The likely causes of the DTC P0204 include a malfunctioning injector relay, which may not supply adequate power to the injector. Open or shorted wires in the circuit could interrupt the flow of electricity, essential for injector operation. Additionally, a faulty injector itself could lead to improper functioning, causing this error code. The PCM might also be the source of the problem if it fails to send the correct signals to the injector control module. Investigating these components is essential for accurate diagnosis and repair, particularly focusing on the wiring connections and functionalities of each component involved. Symptoms of DTC P0204 often manifest as engine-related issues. One prevalent symptom includes the engine not starting or having difficulty starting, particularly if the injector circuit is completely inoperative. Additionally, drivers may experience poor acceleration, where the engine struggles to gain speed or power, indicating a lack of fuel delivery. Unusual engine noises, such as rough running or misfires, may also be present due to unburned fuel in the exhaust system. These symptoms together not only point towards the injector circuit malfunction, but could also lead to further automotive complications if left unaddressed. The first troubleshooting step involves confirming the status of the DTC. Begin by switching the vehicle to the on mode without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to clear the DTC. Once cleared, attempt to start the engine. Important note: if the vehicle uses a keyless access system and does not start, continue cranking for up to 20 seconds to ascertain if the engine will initiate. Following this, check the HDS for any pending or confirmed DTCs again. This step is crucial as it verifies if the problem is ongoing or intermittent, which refers to issues that may not consistently repeat. In this step, assess whether the engine started successfully. If it did, proceed directly to step 11 for further diagnosis. If it failed to start, that indicates a likely existing issue in the injector circuit requiring an in-depth investigation. It's crucial to take note of the engine's behavior during this test, as any irregular sounds or starting difficulties should be documented. The outcome of this step will determine the next appropriate actions to take. ensuring you are systematically addressing the potential failure points rather than guessing where the problem lies. For the third step in the troubleshooting process, first turn the vehicle to the off lock position. Then, remove the injector relay located in the underhood fuse relay box for testing. Inspect the injector relay using a multimeter to determine if it is functioning properly. A relay should allow electrical current to flow at a designated voltage when activated. If not functional, replace the injector relay. This step is critical, as a faulty relay can prevent the injector from receiving the necessary power, leading to the P0204 error code being displayed. In this fourth step, you should switch the vehicle to the on mode with the injector relay disconnected. Then, measure the voltage between specified test points, the injector relay socket number 3 and a solid body ground. If you detect battery voltage at this measurement, continue to step 5. If no voltage is present, an open circuit may exist within the IGP wire between the relay circuit board and the injector relay itself. Addressing this issue might involve repairing or replacing the damaged wire. Verifying voltage is essential to ensure that electrical flow reaches the injector relay. For step 5, turn the vehicle to off lock mode and measure the voltage between the injector relay socket number 1 and body ground. This checks if there's battery voltage present in the +B INJ line, while ensuring the injector relay remains disconnected. A voltage reading indicates that the wiring leading from the +B INJ wire is intact. If you do not measure voltage, you may need to proceed to step 6 for fuse checking. Checking the voltage on this line is pivotal in determining where the issue may lie, either at the fuse or further down the wiring harness. Step 6 entails checking the integrity of fuse A12, rated at 20 amperes, located in the underhood fuse relay box. Inspect if the fuse is operational. A blown fuse would indicate a short or excessive resistance in the wire connecting the +B INJ line to the injector relay. If the fuse is intact, repair any shorts in the wiring, leading from the fuse to the relay. Conversely, if the fuse is blown, it's essential to replace it with a new one and address possible wiring issues to prevent future fuse failure. This inspections cement vital early findings in determining whether a fuse issue exists. In step 7, switch the vehicle to on mode while keeping the injector relay disconnected. Measure the voltage between the injector relay socket number 3 and number 4. Detecting battery voltage here indicates the injector relay and its connections are working correctly. If voltage is absent, it signals possible failures in the INJ RLY line and requires further exploratory steps to trace the issue. It's critical to identify where the circuit may be failing to effectively guide you toward an appropriate resolution. Step 8 involves turning the vehicle off lock mode. Jump the SCS line using the HDS for a minimum of 1 minute, and then disconnect the PCM connector A. Now, check for continuity between the injector relay socket number 4 and PCM connector number 17. Under these conditions, continuity signifies that the INJ RLY is intact, meaning you should then focus on connections at the injector relay, control module, and the PCM. If no continuity is detected, there may be an open in the wire that needs repair. This step allows you to isolate circuit failures effectively without complete disassembly. For step 9, the vehicle should be turned off lock with the relevant connectors disconnected. Jump both terminals A and B of the injector relay socket to create a direct route for testing. Then measure the voltage at the injector control module connector number 1 while grounding appropriately. Presence of voltage here indicates that the circuit is functional. If no voltage is measured, it suggests an open circuit issue that needs to be addressed between the injector relay and the injector control module. Correctly identifying failed connections aids in streamlining your troubleshooting efforts. Step 10 continues similar functionality checks as Step 9, altering the focus to the injector control module connector number 2 for voltage across the INJ-RLY outline. Using the same procedure, measure voltage with all previously mentioned connectors still engaged in a disconnection state. A proper voltage reading signifies that the circuit leading from the injector relay to the control module is intact. Conversely, should you observe no voltage, this would point toward another open in the INJ-RLY outline that must be rectified to restore normal operation. This systematic checking reinforces effective debugging strategies. Step 11 involves reconnecting the relevant connectors after the previous testing procedures and re-inspecting the injector control module's wiring. You will perform continuity checks between injector control connections and the associated PCM points. Obtaining continuity signifies what was previously suspected. The wire's integrity remains intact, enabling further focus on other locations, such as the PCM or other relays. If continuity is lacking, despite previous tests showing potentially functional components, exploratory repairs may need to explore any potential failures that were not immediately apparent. Proceeding to Step 12, it's vital to confirm the continuity of the INJ-F2 line by disconnecting the corresponding PCM connector C and conducting the same previous measures. If continuity exists, this confirms you can eliminate any failures in this wire, ensuring the connection is appropriate. If no continuity is detected again, it indicates an open circuit in the connection between the PCM and the injector control module. The nature of this step strengthens the troubleshooting by logically checking against previously established potential faults, ensuring a thorough examination. During Step 13, focus on checking continuity between the connections of the injector control module, along with the number 4 cylinder injector. This step further verifies whether any disconnection exists that could contribute to the DTC P0204 readings noted earlier. If continuity is confirmed, you can closely look into components potentially rendering stable operation, while lack of connection prompts immediate repairs to restore function. Following logical, sequential testing effectively narrows down the source of problems, maintaining the integrity of accurate diagnostics. In Step 14, disconnect the number 4 cylinder injector connector and perform continuity checks once again. This examination is central to isolating failures that might reside specifically within the injector circuitry for the number 4 cylinder. If continuity surfaces within this circuit, it verifies the original components function appropriately. In contrast, failure to detect continuity suggests breakdowns needing repair in the wiring between the injector control module and its designated injector. Diligently scrutinizing every connection ensures a systematic approach throughout the diagnosis process. Step 15 requires checking the INJ-LS4 line for continuity as the next prioritized task. By ensuring consistent assessments on wire connections, you can comprehensively diagnose any faults representing either the injectors or their associated wiring mechanisms. If continuity persists positive, consider replacing all injectors as a complete set to maintain engine harmony and efficiency. If discontinuity manifesting persists is noted, repair any faults in the LS4 wire line itself that contributes to injector's delivery performance. Utilizing a holistic approach to the injector circuitry ensures coherent engine behavior, making for a smoother running vehicle. In this step, we will conduct a shorted wire check specifically for the INJ-TI4 line. This requires voltage measurements between the injector control module with respect to ground to identify any short circuits. Discovering voltage here suggests an electrical short exists, directly impacting the injector's operational capability. If the test passes with no voltage found, you will move to the next sequence of steps. Evaluating short circuitry aids in ensuring a complete and robust diagnosis of electrical systems across the engine, specifically those affecting fuel delivery protocols. Step 17 follows on from the prior methodology by checking the INJF2 line for similar short conditions. Continue this assessment by measuring the voltage against ground for potential circuit failures that could inhibit injector performance. Should there be any voltage present, it indicates a short to power potentially damaging in nature and requires repair. If no voltage is measurable, delineate towards the next systematic checks ensuring power is effectively distributed throughout necessary circuits during operations. This consistency is paramount, laying the groundwork for comprehensive diagnostics. For Step 18, return to the process of checking for issues within the INJ-HS4 line. By measuring the voltage under on mode reveals whether the circuit is open or potentially experiencing faults. Should measurements appear favorable, indicating functional wiring, proceed to investigate further actors influencing the number 4 cylinder injector. If faults appear uncured upon testing, you may need to consider other lines of inspection for responsible parties, affecting entire injector circuits, such as grounds or power junctions presenting higher resistance. At Step 19, you shift focus toward checking the INJ-LS4 line for similar connectivity checks under these rigorous conditions. This requires voltage assessment relative to the body ground. By capturing anomalies throughout the test, it becomes clear whether a wire is shorted to power, affecting total operational capacity for the cylinder injector. Secure both readings and any required repairs, proceeding according to diagnosis findings through voltage checks and wiring integrity. Ideal functionality is reliant on consistent results through this well-structured protocol. In Step 20, look to identify any integrity issues within the INJ-TI4 line, focusing on completion with continuity checks. This process ensures robustness in the circuit by examining connections under the boundary of ground functionality, paired with the underlying PCM. Each pin and connection warrants thorough review for necessary repair if continuity proves faulty. Balancing up all observations through these detailed explorations enriches exact outcomes seen in wiring operations, ensuring comprehensive injective efficacy across all cylinders. Final repair verification calls for a complete review of all diagnostic results accumulated throughout the troubleshooting process. After performing all necessary repairs and corrections, it becomes imperative to validate operational capacity through engine testing once again. Reassessing DTC presence post-repairs ensures that all prior fault conditions have been adequately resolved, paving the way for stable engine performance. A successful verification guarantees that the P0204 code will no longer reappear during startup and operational testing, confirming proper system rehabilitation without lingering issues tying back to injector circuitry. Preventive maintenance plays a critical role in ensuring the longevity of the injector circuit and overall engine function within the Honda Pilot. Regularly scheduled component checks, coupled with routine inspections of electrical connections, mitigate risks of future injector circuit malfunctions. Keeping connectors clean and ensuring that grounding spaces remain free from corrosion is essential to prevent intermittent faults. Additionally, inspecting wiring for wear and tear, particularly in high-stress areas or corners, can greatly reduce the chances of shorts or opens in the circuit. By instituting a proactive maintenance schedule, owners can significantly reduce diagnosis time and repair costs, ensuring smooth vehicle operation. In conclusion, DTC P0204 requires thorough diagnosis and examination to ensure accurate identification and resolution of injector circuit malfunctions. The systematic troubleshooting steps provide a structured means to isolate and rectify faults, ultimately restoring vehicle performance. Special attention to wiring, connectors, and circuit integrity enhances reliability and prevents recurrence of issues. Regular preventive maintenance can ensure minimizing costs associated with repairs by preventing catastrophic failures down the line. Understanding these methodologies aids technicians and owners alike in maintaining operational health of their Honda Pilot engines. Please like and subscribe to the channel. See you next time.